Have you ever looked up at the night sky, truly looked and felt a profound sense of wonder? It is a feeling that connects us across all of human history. From the earliest campfires to our modern brightly lit cities, we have gazed into the darkness and asked the same fundamental questions. Where did all of this come from? How did it all begin? The stars, scattered like diamond dust across an infinite velvet cloth, are not just beautiful points of light. They are storytellers, each one a sun, many with their own families of planets. They are the descendants of a cosmic story that began long, long ago. The scale of the universe is almost impossible to comprehend. Our own galaxy, the Milky Way, contains hundreds of billions of stars. And there are hundreds of billions of galaxies in the observable universe. It is a staggering thought. This vast cosmic web of galaxies and stars and planets all originated from a single point, an event we call the Big Bang, which happened some 13.8 billion years ago. For most of human existence, this origin story was the stuff of myth and philosophy. But in the last century, science has given us the tools to start piecing together the actual history of our cosmos. To look out into space is to look back in time. This is a simple but profound truth. Light, as fast as it is, does not travel instantaneously. The light from our own sun takes about 8 minutes to reach Earth, so when we look at the sun, we are seeing it as it was 8 minutes ago. For many years, our greatest time machine was the Hubble Space Telescope. Launched in 1990, Hubble revolutionized our view of the cosmos. It gave us breathtaking images of distant galaxies, swirling nebulae, and the birth and death of stars. But even Hubble had its limits. The universe is expanding. As it expands, the space between galaxies stretches, and the light traveling through that space gets stretched along with it. The most distant objects, the very first galaxies we want to see, are so far away that their light has been stretched all the way beyond the visible spectrum into the infrared. That dream became the James Webb Space Telescope, or JWST. It is not just an upgrade to Hubble, it is a fundamentally different kind of observatory. Its primary mirror is a stunning piece of engineering, over 6.5 meters in diameter, composed of 18 gold-coated hexagonal segments. To solve this, JWST was designed to operate in the freezing cold of deep space, far from the warmth of the Earth. It orbits the Sun 1 million miles away from our planet, and it is protected by a giant 5-layer sunshield the size of a tennis court. This sunshield keeps the telescope and its instruments at a frigid -233 degrees Celsius. By looking in the infrared, Webb unlocks a completely different universe, one that has been largely hidden from us. It is like gaining a new sense. Infrared light has a longer wavelength and can pass through these dust clouds much more easily. For Webb, these opaque clouds become translucent. To unlock the secrets hidden within that light, Webb is equipped with a suite of 4 extraordinary scientific instruments. A spectrograph takes the light from a single object and splits it into its constituent colors, creating a spectrum. This spectrum is like a chemical barcode. The first galaxies were something else entirely. They were the very first collections of stars to light up the universe after the cosmic dark ages. Imagine them not as fully formed structures, but as cosmic nurseries, small, chaotic, and intensely bright knots of creation. These first stars were unlike any that exist today. Theory predicts they were monsters, hundreds of times more massive, burning millions of times brighter, and living incredibly short, violent lives. A collection of these behemoth stars would have formed the core of an infant galaxy. The search for infant galaxies is honestly one of the most daunting observational challenges ever undertaken. The light from these first galaxies is incredibly weak. Photons that began their journey more than 13 billion years ago have spread out over an unimaginable distance. Not every faint red dot that Webb sees is a record-breakingly distant galaxy. Other, closer objects can masquerade as the real thing. Astronomers have to perform meticulous detective work, using Webb's suite of instruments to carefully analyze the light from each candidate. One of the very first breakthrough observations came from a program called GLASS. This clever program used a fascinating trick of nature to its advantage. It pointed Webb at a massive cluster of galaxies, a colossal object called Able 2744. Within the very first batch of data, they found something extraordinary. One of them, named Glass Z13, was a candidate for the most distant galaxy ever seen at the time. The discovery sent shockwaves through the astronomical community. It was announced just weeks after Webb began its science operations. As Webb continued to scan the heavens, another remarkable candidate emerged from a different deep-field survey. They nicknamed it Maisie's Galaxy, after the lead scientist's daughter, as it was discovered on her birthday. Initial analysis suggested that Maisie's Galaxy was shining its light when the universe was just 290 million years old. Finding a galaxy this early would be a monumental discovery. It would mean that the process of galaxy formation started even earlier and progressed even faster than many of our models had predicted. For months, these early galaxy candidates existed in a state of scientific limbo, a bit like Schrödinger's famous cat. The process of spectroscopic confirmation is incredibly difficult. It requires pointing Webb at a single, tiny, faint object for many hours. In early 2023, the results began to come in, and they were, honestly, spectacular. They successfully obtained spectra for several galaxies, confirming their existence at a time when the universe was less than 500 million years old. Perhaps the most mind-bending discovery from Webb's first year of science was not just that early galaxies existed, but that some of them were, honestly, shockingly massive. According to our standard cosmological model, galaxies grow hierarchically. Small clumps of matter and stars form first. This was, to put it mildly, a huge problem for our theories. It was like finding a fully grown adult in a nursery full of newborns. This finding has sent theorists and simulators scrambling back to their drawing boards. The flood of data from the James Webb Space Telescope is doing more than just adding new details to our cosmic story. It is forcing us to pick up the pen and rewrite the entire first chapter. For decades, our understanding of the early universe was governed by a clear and elegant narrative, the Lambda CDM model. The timeline of cosmic history appears to be radically compressed. The universe did not slowly wake from its slumber after the Dark Ages. It burst onto the scene with a flurry of creative energy. The neat, linear story of cosmic evolution is being replaced by a more chaotic, dynamic, and frankly, more interesting one. Using its powerful spectrographs, Webb can analyze the light from these galaxies to reveal their chemical composition. This is like performing a cosmic DNA test. One of the most surprising findings is the unexpectedly high abundance of heavy elements, what astronomers call metals, in these primordial galaxies. Finding significant amounts of elements like oxygen, carbon, and neon in galaxies that existed just 400 or 500 million years after the Big Bang is a major clue. The universe, it seems, was very quick to bootstrap itself into a more complex and chemically diverse state. The James Webb Space Telescope is more than just a scientific instrument. It is a profound shift in our perspective, a new lens through which we view our place in the cosmos. The faint, ancient light from the universe's first galaxies, which traveled for over 13.5 billion years to reach us, is now falling upon Webb's golden mirror. The images and data from Webb are not just for astronomers. They are a shared human heritage. They remind us that we are part of a grand, unfolding narrative of cosmic proportions. It is a reminder that we are all inhabitants of one tiny, precious planet, adrift in an ocean of galaxies, whose depths we are only just beginning to plumb. As breathtaking as the first year of discoveries has been, it is crucial to remember that this is only the beginning. The James Webb Space Telescope is designed to operate for a decade or more. What lies ahead is a long and systematic exploration of the cosmic frontier. The next chapters of Webb's mission will see it push even further into the unknown. And in one of its most exciting applications, it will study the atmospheres of exoplanets, worlds orbiting other stars, searching for the chemical fingerprints that could be signs of life. And as Webb continues its silent, cold vigil a million miles from Earth, it promises to deliver many more revelations that will challenge our assumptions and expand our horizons. The greatest adventure is underway, and the journey has just begun.